take 232. What we have over here is a curved mirror, and it curves inward, so we call this a concave mirror because it caves in. And we're going to build off of the ideas of light reflecting off of mirrors. Not a flat mirror anymore, of course, though, but a curved mirror. Let's, though, recall some stuff from the flat mirror. The flat mirror had what we called a normal, which was perpendicular to the surface. Now, if we kind of just look at the middle of the mirror here, where you see my fingers, it's kind of almost all vertical right there. So perpendicular to that would then be the perfect horizontal. So right in the middle, my normal is horizontal. And if I shine a light ray exactly on that normal, it should then reflect exactly back on that path, which it does. We didn't do too much of that. What we did is we actually shined it in at angles other than what lines up with the normal. So for instance, over here, if I shine this in at the exact same spot, okay, the normal being the horizontal, this comes in at an angle to the horizontal, maybe 25 degrees or something, and reflects exactly 25 degrees on the opposite side of the normal. Cool thing is, if I put that beam there, that's actually the normal. So you see the symmetry, we already talked about that, okay? Here's the issue though. Well, what if I don't shine a light ray in exactly in the middle where it's perpendicular to the surface of the mirror? So for instance, what if I shine in a horizontal light beam up here? It's definitely not going to bounce straight back because the mirror is curved a little bit. Now, if you play sports or just throw balls against walls or something like that, you'll know based off of this angle, it's definitely not going to bounce straight back. It's probably going to reflect downward. So, what does that mean? It means that up here, the normal is not horizontal anymore. It's actually a little bit at an angle, which it looks like it would be approximately there because, again, it's got to come in at the same angle as it reflects on the opposite side. All right, so the general idea, which kind of stinks, is that there's a lot of different normals on this curved mirror because the surface of the mirror, it changes everywhere. But we're going to learn a new pattern. What if I actually just continue sending in these horizontal light rays? What maybe will the reflected rays do? Well, they'll probably all reflect differently, but let's see if we notice something. So they came in parallel again, all right? But look at what the reflected rays do right here. They meet, they intersect, or they converge. You might hear this mirror called not only concave, but a converging mirror, because these parallel light rays, when they come in, the reflected rays will actually meet and converge together. This actually will happen for every single parallel ray. You can see all 5 of the reflected rays, even though the other one's right on the normal, they all converge right here. This place where they meet has a specific name, It is very unique and dependent upon the curvature of the mirror. So I want you guys to use your textbook to try to find out, well, what do we call this location and what does it have to do with the curvature of the mirror? Go ahead and answer those questions. Good luck with that.